Hey everybody. Lesson oh we're gonna have a word from our sponsors here. So just listen. Hey, it's Pouch Lawn Care Services here, where we do lawn for people who are too lazy to do it themselves. Pouch Lawn Care, give us a call. Alright, sorry, we're back. Sorry about that. I'm just kidding. Lawn care. I feel like I did a whole day of lawn work today. I should start my own business, man. Alright. So we are doing lesson 24. This is day 4, so it's the green pages in your book. This is actually starting on page 216. We're going to do a variety of problems here. So if you could follow along, try some on your own if you can. See if they make sense. If you have questions, again, bring those to me afterwards. So sorry, a little bit of technical difficulties there. Take a look at the example at the top of page 216. It says study this example, and then we're going to go through the 3 examples after that. It says an older TV screen has a diagonal measurement of 32 inches. So I don't know if you knew that, but TV screens are actually, like if you get a 50-inch screen, that's the diagonal measurement of it. So kind of this dashed line going across the diagonal there, that would be how they measure TVs. The ratio of the width to height is 4:3. How wide is the screen of the 32-inch TV? So the width to height, so W to H, it's saying is 4:3, meaning the width is bigger than the height. And you can see that from the TV. That's how most TV screens are. So it says, look how you can show your work. We're trying to find ultimate. We know this is 32 inches. We don't know either the width or the height, so this is definitely a little bit of a challenge problem. So they said W squared plus H squared equals D squared. And again, that's the Pythagorean theorem. That's what we've been studying for the last 2 sections. Since we have, if you take this diagonal with the width and the height, it's a rectangle, so it makes a right angle. And it makes sense. The 2 legs squared and added together has to equal the diagonal, or the hypotenuse squared. So it says W squared is plus 3/4 of W squared. So where did that come from? Because I know the 32 is coming from the diagonal, but this 3/4 times W. So if the height, the ratio is 4:3. If you reverse it, it's 3:4. That means that for every 3 height, there's 4 width. That is 3/4 of, so the height would be 3/4 of the width. And that's where that's coming from. And that's a little tricky part for this one, especially, but that's why it's done for you, to kind of, so you can see how you could do one of these. So that's put into there in for the height. So this would be 3/4 of the W. Okay. So when you square that, the W gets squared, but also the 3/4 gets squared. So 3 squared is 9, 16, or 4 squared is 16, so 9/16. They put a 16 over 16 in front of here, and that's because 16 over 16 is 1. And they wanted to add them together because they both have W squared, and to add them together, you want to have common denominator. So they did 25/16 W squared equals 32 squared. And then to get the W by itself, you can square root the whole thing because it's all able to be square rooted, and you square root both sides. So what's being shown here is a square root here and a square root there. It'll cancel out the squares, and then you also have to do the square root of 25/16. The square root of that is 5 and 4. So the square root of each of them. So you get 5 over 4W equals 32. And then to get from there, you can divide both sides by 5 over 4 or multiply by the reciprocal of 4 over 5 to cancel out. So multiply by 4 over 5, and you get this number. If you check it on a calculator, you get 25.6. That would be the width of the screen. So all that work, it took a lot of work. This is definitely a challenge problem. So we're going to go through 3 examples after this that are also kind of challenge problems that all involve the Pythagorean theorem. Okay. Let's look at number 14. Mr. Kurdzo wants to store a 12-foot long pipe in a tool closet that is 6 feet wide, 6 feet long, and 8 feet high. will it fit? So we kind of did an example like this where we try to fit a fishing pole in a box. So if you think about the biggest length of a box, if you try to fit it, the height isn't the biggest, the width or the length, it's the diagonal, the going across. So that's that. If you can visualize it going from this point all the way back to this point, that's the diagonal line. That's what we're trying to figure out if it'll fit. And to get there, we're going to have to use the Pythagorean theorem a couple times. So again, this is a right angle, but we don't even know what the C is. So to use the C, we want to look at this bottom right triangle because this would be a right angle as well. Because it's a rectangular prism, it's a box, so it would have all right angles. So 2 steps. One is to find C, and C is the hypotenuse of the 6 by 6. So 6 squared plus 6 squared equals C squared. I know that 6 squared, or 6 times 6 is 36. You probably do too. Let's add those together, and I think it's 72 right away. 72 equals C squared. Okay, that's where we're at. Last step to solve, take the square root. So C equals square root of 72. Use your calculator, please. Square root 72. What'd you get? I got 8.5 if you round it. It's not perfect, so we're going to do approximately equal to 8.5. Okay. Now, one thing I'd like you to do, well, let's actually run, yeah, we'll leave it at 8.5. Now, let's take that 8.5, which is C, and this bigger triangle, which you can kind of visualize going like this, right angle. Our C is now 8.5, our height is 8, and we don't know the diagonal. But that's the hypotenuse. It's across from the right angle. So that's our C value in our Pythagorean theorem. So 8 squared plus 8.5 squared equals D squared. 64. 8.5 is about, or squared, and I have installed my calculator. I'm just going to hit the squared button. Exactly 72. So that's what we had before. Equals D squared. 72 plus 64 is 136. And last step to solve for D is the square root. Square root of 136. On my calculator, I got about 11.7 if I round up. And that would be inches. So the diagonal is 11.7 inches. Mr. Kurdzo wants to store a 12-foot pipe. Is that going to fit? Sorry, Mr. K. Not going to fit. Nope. Too long of a pole to fit. Because we only have 11.7 inches to work with. It's not going to work. So there's one application that we've done using 3D models. Let's go to number 15. It says a right triangle has a hypotenuse of length 20. So let's just say we have this right triangle. Hypotenuse is 20. The lengths of the legs are whole numbers. What are the lengths of the legs? So this is an example where we're missing both the A and the B. And I don't know, this is definitely a challenge problem because we've never solved one where you have to find both. But what we can do is think about all the Pythagorean triples that we've known and go to the very basic ones, because at one point we did talk about it that if it's multiples of them, it'll work as well. So if I'm going to take the very most basic Pythagorean triple, meaning 3 whole numbers that work for the Pythagorean theorem, and that's 3, 4, 5. Now, I know 5 would be the hypotenuse, and if I were to get to 20, that would be times 4, so it's 4 times bigger. So I can do the same thing with the 4. 4 times 4 is 16. And the 3 times 4 is 12, and it should work. And our answers should be 12 and 16 then. But let's double check then to see if that works. Is 12 squared plus 16 squared equal to 20 squared? This is what we're hoping works. 12 squared, I know that one is 144, and maybe you do too. If not, just check it on your calculator. 16 squared, 16 times 16 is 256. So if I add those together, 256 plus 144 is 400. 20 squared, I think, is also 400. So it is. So that means it works, meaning what are the lengths of the legs? If we know their whole numbers, the lengths of the legs are 12 and 16. That's the only answers that it could be for whole numbers. Now, you could have taken any number. Like, you could have said 10, A was 10, and you could solve it for B, and it would work. It would be you'd find a decimal, though. So this is the only way we can know for sure that the whole numbers are. You have to start looking at Pythagorean triples. That's what those are. That was a tough one, too. Let's try another one. Number 16, Mr. Hill is building a walkway from the corner of his house out to his vegetable garden in the corner of the yard. The dimensions of the yard and the garden are shown. So this must be the corner of the house right here. What is the length of the walkway to get to the garden? So we're trying to find W. How does this apply to the Pythagorean theorem? I don't see any right triangles, but I do see right angles. So we're trying to find W, and it looks like it could be considered a diagonal here. We just need to make a right triangle somehow. And I would either go straight to the left or straight up and down. I would go straight up and down just because then I can see the right angle here. The problem is, do we have this length or this length? The two legs. Well, we can find them. If we know this whole yard is 30 feet deep, and I know this part was 14, 30 minus 14 equals 16. That means this is a 16 right there. Same idea here. We know this whole width of the yard is 50 because it says it on the bottom. And we knew this part was 20. So 50 minus 20 gets me 30. So I've got 30 foot length there for the leg of that triangle. And now I have a triangle. I have a right triangle, and I know two of the sides, so I can simply find the third side. Okay, so I'm going to take my Pythagorean theorem, 16 squared plus 30 squared, and I'm finding the hypotenuse, so that's W squared. And let's figure these out. 16 squared, we actually did in the last example, and I think it was 256. So 256. 30 squared I know because 3 times 3 is 9. So it would become 900 because there's 2 zeros. Add those two together, 256. And you get 1156. And remember, last step would be to square root to get the W by itself. No more squared. So square root of 1156 is an exact 34. And here we go. B is 34 feet. How awesome is that? All right, final thing. Adam chose C as the correct answer. How did he get that answer? So C, 46. Why don't you take a look at the Pythagorean theorem? We did 16 squared plus 30 squared equals W squared. One of the most common mistakes that I see with people is they forget the squared. They just think that A plus B equals C, and that just doesn't work. But in this case, if you did 16 plus 30 equals W, 16 plus 30 is 46. I'm guessing that's what Adam did. And you got 46 feet, but it definitely doesn't work. We just showed that the W is actually 34 feet, which is significantly smaller. So that doesn't work, but that was the error. My guess was his error. All right. So there's section 4 of lesson 24. I did want to just peek at one other example, I think, for the next page. No, we're going to leave it at that. All right, so just again, we've been working with, I didn't put our learning targets up for this lesson, and I'm sorry about that, but we're continuing to just, really it's right at the top, solve problems using the Pythagorean theorem. And we just had 3 different examples of 3 different ways you could use the Pythagorean theorem and apply it. Find ways to use right triangles and find missing parts. And really, this first example, if you didn't know that, TVs are measured by the diagonal, and you can use the Pythagorean theorem to find that very easily. Or if you want to find the exact measurements. So again, continue to apply the Pythagorean theorem. A squared plus b squared equals c squared, and that is for right triangles only.